Hello, hello. In this video, we're gonna talk about numeric representation of data, and this covers material from Unit 3. Actually, this is an intro to Unit 3. So, when studying data, the goal is to have the visual summary that tells the story. So we want to take a look at what shape is our data at, when presented visually. Is it normally distributed? Is it J-shaped? Is it skewed left or right? But sometimes the visual summary is not practical. For example, if we have to send the data over some not very modern technology, for example, telegraph, and um, we could actually summarize the visual representation into numerical summary of the data. And later, that numerical summary can be interpreted to describe the shape of the distribution. So let's take a closer look at numerical summary of data. So there are three types of numerical measurements that we will go over in this unit. So we're going to talk about the measures of center or measures of central tendency, and they describe what's considered the most typical observation in the data set. The next one is the measure of variation or spread, and that describes how much data values vary from that central value. In other words, other data measurements more or less alike, or are they very different among each other? And the next one is the measure of position or the measure of relative standing. And basically, that measure describes the position of an individual observation in the data set, and it compares it to the measure of center or the central or most typical value. So here's the definition of the measure of center mean. And by the way, there are three different types of the measure of center. So the first one is mean. The mean of a data set is the arithmetic average of all observed values. And to calculate the mean, we're going to find the sum of all of the observations, and then we're going to divide that number by the number of observations. And we're going to do this in a second on a paper, but I just want to mention that we can calculate the mean only if we're dealing with numerical or quantitative data. You cannot find the mean of a qualitative data.
So in the first example, we have the heights of 5 students given below in inches. And the objective is to find the mean of student heights. So what we're going to do, as we mentioned, we're going to add up all the values, 60 plus 67 plus 73 plus 65 plus 67. We're going to add them up and then we're going to divide them by the number of observations. So here we have 5 observations, so we're going to divide it by 5. Once we put all of those values into a calculator, we get a sum of 332, and divided by 5 is going to give us 66.4. I want to remind you guys that you have to either push enter once you entered all numbers being added and then divide by 5, or include the sum into parentheses, because if you don't, then your calculator will divide only the last number, not the sum. So be careful about that. So example number 2, now exclude the tallest student from the calculation and calculate the mean again. And I want you to do this exercise by yourself. So you're excluding 73. Now you have only 4 values. What is your mean? Let me know. Meanwhile, I would like to go over some notation. So the mean of the sample is denoted by X with a bar. We're going to assume this is a sample from the class. It's not the entire class, but just the sample. So we're going to use X with a bar. Okay. A couple of other notations that are very useful, and you will see in the formulas. The first one is the Greek letter sigma, which represents the sum. Basically, whenever you see this letter sigma, that means add up values. So if you see this sigma followed by X, that means add up all X values. Also, for the X values, we're going to use subscript. So X with a subscript 1 means the first value, the first X value. And X with a subscript N means the nth X value. So if we were to write down the formula for the mean, it would look like this. Add up all X values. Xi means I is a counter. It takes on all the values of X from the first one to the last one. The total number of X's is N, and we're going to divide that by the total number of values, N. So N is the sample size, which is the number of values in the entire sample. As I already mentioned, it's not always practical to find the mean, because mean is arithmetic average and it can be applied only to quantitative data. What about qualitative data? And even quantitative data? Another measure of center that we can use is the median of the data set. And it is the middle number that divides the bottom 50% of the data from the top 50% of the data. Okay, so how do we find the median? So here again, we have the heights of 5 students. And in order to find the median, first we have to rearrange our data set from smallest to largest. So arrange in ascending order. We could arrange it in descending order as well. It doesn't really matter as long as it's in order. I like to arrange it in ascending order. And then literally we find the middle value. So if we start crossing out numbers by 1 from the top and the bottom, 60 and 73 will go away. Those are considered our most extreme data values. And then the next 65 and 67 go away, and the value in the middle is 67. So 67 is the median for this data. That's the value in the middle. Okay, the notation that we use for the median is X with a wavy line above it. It's red median. This wavy line is called tilde. So it's X with a tilde. So the median for this data set is 67. Now, why would we use median for quantitative data when we could use mean? The reason is the mean is very sensitive to extreme data set. So imagine if there was one really, really tall person here instead of 63 inches tall. Let's say we would have somebody like 82 inches tall. And that would throw off the average by a lot. So the average is no longer representative. So mean is very sensitive to the extreme data values, but when median is not. So that's why we could use median instead of the mean, one of the reasons. All right, so the question is, how do you find the median when your data values is even? So if it's odd, then you're going to have a definite value in the middle. What if it's even? Then once you start crossing out the values, you cross out 60 and 73, 65 and 67, there's nothing left, right? So what you're going to do, you're going to average out the values to the left and to the right of the middle position. So it's going to be 65 plus 67 divided by 2. It's going to be 66. So median for this data set is 66. Again, what is the formula? So we're going to find the place of the median or its order number. That's n plus 1 divided by 2. Okay, so that's the place of the middle number. So for this data value, it's going to be 5 plus 1 is 6, divided by 2 is 3. So this would be the data value number 3. So you can count down 1, 2, 3. That's your median number. So, and for this data set, we have 4 values. So n plus 1 would be 5, divided by 2 is 2.5. So 2.5 is in the middle between value 2 and value 3. And that's why we're going to average it out. The next measure of center that we're going to be talking about is mode of the data set. The mode of the data set is the most frequently occurring value in the data set. So this is, so for example, when would it be useful? For example, we're looking at an athlete who is jumping, a distance jumper. So we want to see how consistent are his results. Is he consistently jumping very far, or like if he jumped far, it's a one-off, or is it a consistent value? So that's what mode will help us to determine. So the mode is the number or the value that occurs more often than any other value in the data set. So here's an example. The heights of 5 students given below. Find the mode. There is no symbol that we have for the mode. We're just gonna write mode. Mode of the data is most frequently occurring value. For this data set, it's 67. 67 occurs the most. Now, let's say that we had another value of 65 here. So now 65 would occur the same number of times as 67. We would say that this data set has two modes. Okay, two modes that occur the same number of times. Now, what if, in addition to this 65, we had another 67? Now, 67 again is the most frequent value. So this data set will have only one mode, which is 67, because it occurs more than 65, even though 65 occurs few times as well, but 67 occurs more. So the mode is the most frequently occurring observation, more than other. So others could repeat as well, but the one that repeats the most is our mode. Okay, so what's the mode of this data set? Well, there is no value that actually repeats more than any other value, so this data set has no mode. And for the next one, well, we already discussed it right here, has two modes. It's a bimodal data set. So the modes are 65 and 67. And we could include it, make it a set included in braces, in square braces, indicating that it's a set of values. So here's a summary for our measures of center. Mean, it's used for quantitative data only, and it is sensitive to the influence of extreme observations. So very low lows and very high highs. Median is used for quantitative data. I would not say only, it's used for the qualitative data as well. It is a resistant measure, meaning it's not influenced by low lows or high highs. And another one is mode. This is the one that's used for mostly quantitative, but also, actually, no, I'll take it back. It's used for both quantitative and qualitative data, and it's the value that occurs most often. So here's that's it for this video, and in the next video, we're gonna talk a little bit more about resistant measures of center.